Hello everyone, this is Maushami and I am here to present the concepts of physics in a lucid manner. Now, what is physics? Physics is omnipresent. What does that mean? Whether we understand or we don't, we use physics every day. Physics is basically the study of matter and energy. Now, one of the broad branches of physics is classical physics, which deals with motion of objects. Yes, we are into motion now. Let's see what I have in store for you. So this is kinematics. Kinematics is basically the branch of mechanics that deals with the motion of objects without considering the forces that actually can cause motion. So we have covered the following subtopics under kinematics, and these are the list of reference books that have been followed. Now going back to motion, what is motion? Motion is basically the change in position of an object with respect to a particular frame of reference. Now what does that mean? Rest and motion, these are two relative terms. You must have seen passengers sitting in a moving bus. They feel as if they are at rest within the bus. But to an observer who is outside the bus, what does he see? He can see both the passengers as well as the bus moving with a certain velocity. So this means that rest and motion, they are both relative terms perspective to the observer. Now motion may be one-dimensional. What is one-dimensional motion? You can see one-dimensional motion is motion along a straight line. For example, motion of cars flying on the road. So one-dimensional motion could be somewhat of this sort. So this is one-dimensional motion. This could also represent one-dimensional motion, and this could also represent one-dimensional motion. Now coming to two-dimensional motion is motion along a plane. It involves x and y coordinates. You must have seen the motion of a stone. It has got both x coordinates and y coordinate. Let me show this with a diagram. Suppose this is the x-axis and this is the y-axis. So if you want to represent the motion of a stone here, it's somewhat like this. So you can see for any point on its motion, say this is the point P, we have both x and y coordinates to specify this point. We have an x coordinate and a y coordinate. This will give us the x coordinate and this is the y coordinate. So this will define the position of the stone at any instant of time. So what we can see is this two-dimensional motion is nothing but a sum of two one-dimensional motions. Now we come to the different parameters that are used to describe the motion of objects. The first parameter, distance. We all know what distance actually means. Distance is the length of the actual path between the initial and the final position of an object with respect to time. So what does this actually mean? A particle may be following different paths to reach another point. Now distance is basically dependent on the path that is followed by the particle. Let me have a look at this example. A particle is following a triangular path. Say we have this triangular path as A, B, C. This is A, B and C. AB has a distance of say 4 meters. BC is say 3 meters, or it would be advisable if I would have taken this as 3 and this as 4 as per the diagram, and this is say 5 meters. So now if I am asked to calculate the total distance covered, the total distance will be AB plus BC plus CA. So this is 4 plus 3 plus 5, which gives it as 12 meters. So you can see that to specify distance, we need a numerical value and an unit. So this makes distance a scalar quantity. Distance is a scalar quantity, its SI unit is meter, and it is always positive. It can never be 0 or negative. Let's now come to displacement. Now what is displacement? Displacement is the change in position of a particle in a particular direction over a given interval of time. In fact, if we want to find out the displacement between 2 points, it is actually the shortest distance between the 2 points. Let us try and understand what this actually means. We have the same diagram here. This is A, B and C. Suppose the particle is moving from A to B, a distance of say 3 meters, from B to C a distance of 4 meters, and from C to A distance of 5 meters. Now if I ask you to find out the displacement, how will you do so? Now you have to recall the definition. What is the definition of displacement? It is the change in position in a particular direction. Now take a note on this diagram. The body initially started from A and it came back to A. So there is no change in position in this case. So what will be the displacement? It's 0. So displacement is 0 here. I have in hold another example for you which will clear your concepts. To add to this, displacement is a vector quantity because we have to specify the direction in which the particle is moving. Its SI unit is again same as that of length. It can be positive, negative or 0. This was the case where the displacement is 0. Now I'll show you cases where displacement can be positive or negative. Let's have a look at that. Now this is the diagram. You can see the particle is moving in a semicircular path. So say this was the initial position A, this is the final position B, and the radius of this semicircular path is 7 meters. Now here, can you tell me the distance covered? Here distance will be the actual path followed by the particle in moving from the initial to the final point. So you can see this is a semicircular path, and we know that whenever a particle is covering a circular path, it means that it has covered a distance equal to 2 pi r, where r is the radius of the circular path. Since this is a semicircular path, so it will be half of the total, that is half of 2 pi r, which is pi r. So this distance here is pi r, so pi is 22 by 7 and r is 7. So it comes out to be 22 meter. So this is the distance covered. Take a note, in calculating the distance we have considered the path followed by the particle, the actual path. Now how do we find the displacement in the same problem? Displacement will be equal to the shortest distance between the initial and the final position, and the shortest distance is always the perpendicular distance. So you can see the shortest distance travelled by the particle in going from A to B is double the radius. So this is 2 r. So let me correct this. This has to be capital R. So this is 2r. We can put the values. 2 times 7, which is 14 meter. So this is the displacement here. So you see that displacement is positive here. Now when can displacement be negative? Suppose the particle has travelled some initial distance and then it comes back and travels less distance than the initial one. So under this condition, you'll see that the initial distance covered is more than the final distance. So the difference will be final minus initial, which will give us a negative value. So under such cases, the displacement of the particle can be negative. Now let us move forward. We have some very important parameters that are very much required while solving numerical problems. Now the first one of it, speed. You must have seen boys moving on the road with high speed bikes. You might be wanting to ride one. Anyways, speed is the distance covered by a particle in a given interval of time. Let me jot out a formula for this. Speed equals distance over time. So the SI unit of speed will be meter per second. Now speed can be uniform or variable. Now what is uniform speed? A particle is said to be moving with uniform speed if it covers equal distances in equal intervals of time. Let me help you understand this definition. Now these intervals of time might be very small, but that doesn't affect the motion. So suppose the particle is moving from A to B. Mind it, we are not concerned with the direction as this is speed, which is a scalar quantity. So the particle travels a distance of 2 meter in say 1 second, and then it moves another 2 meter in another 1 second, and then another 2 meter in another 1 second. So in this case, we can say that the particle is moving with uniform speed. Now variable speed, a particle is said to be moving with variable speed if it covers equal distances but now in unequal intervals of time. Let us have a look at the same diagram. The particle moves from A to B, a distance of 2 meters in a time of say 1 second, then from B to C, a distance of 2 meters in now say 1.5 seconds, and then another 2 meters in say now 2 seconds. So under such cases you can say that the particle is moving with variable speed, that is at every point of time its speed is changing. Now talking about instantaneous speed. Now just now as I told you, variable speed is that when a particle continuously changes the time in which it is covering the same distance. So whenever such a particle is moving with variable speed, the speed of the particle at any particular instant of time is called the instantaneous speed. So instantaneous speed, we can write a formula for this. If delta S represents the distance travelled by the object in a time delta t, then we can write instantaneous speed as limit delta t tending to 0 delta S over delta t. So this gives us the measure of instantaneous speed. You must have seen the speedometer in a car. A speedometer measures instantaneous speed. Now talking about average speed. What is average speed? Average speed is calculated whenever a particle is moving with variable speed, and it is defined as the ratio of the total distance covered to the total time taken. We can write a formula for average speed as average speed equals total distance over total time. Now, there is a special case to it. Suppose a particle is covering the same distance but with different speeds. Say a particle moves from A to B, a distance d with a speed say s1, and then it moves from B to C, same distance d but with a different speed, say s2. Now, if you are asked to find out the average speed in this case, how will you do that? We shall use the same formula. Average speed is nothing but total distance over total time. So, look at the total distance here. Now, the total distance here is d plus d, and the total time, say the time here is t1 in going from A to B, and the time here is t2 in going from B to C. So, the total time is t1 plus t2. So, we have 2d in the numerator and t1. From the definition of speed, we know that speed is equal to distance over time. So, time will be equal to distance over speed. So, we have distance here d over the speed for this part is s1 plus distance d and speed is s2 for the second part. So, if we solve this, we can see that d will get cancelled out with d and we are left with a beautiful formula, that is 2s1 s2 over s1 plus s2. Now, keep this formula in mind. This formula will be very useful in solving numerical problems. It is one of the formulas that I love the most. So, average speed is equal to 2s1 s2 over s1 plus s2. You only have to keep this diagram in mind. That is, if a particle is covering the same distance but with different speeds, then you directly got to apply this formula. Now, coming to the next topic. There is not much difference between speed and velocity. The only difference is that speed is a scalar quantity while velocity is a vector quantity. Now, what is velocity? Velocity is the time rate of change of displacement of a particle. We can write a formula for velocity from this. Sorry for this is displacement. Displacement over time. Now, the SI units of velocity is the same as that of speed, that is meter per second. It is a vector quantity and it can be positive, negative or 0 since it involves displacement, and displacement can be positive, negative or 0. So, velocity also behaves similarly. Now, uniform motion or uniform velocity. What does this actually mean? Now, whenever I say a particle is moving with uniform motion or moving with uniform velocity, it actually means that the particle is covering equal displacements in equal intervals of time. I will make the definition easier for you with few illustrations. Now, look at this. Here we have the velocity time graph of a particle moving with uniform velocity. You can see that the time changes but the velocity doesn't change. So, this is how a particle traveling with uniform velocity will behave. The velocity time graph is a line parallel to the time axis. Now, if we plot the displacement versus the time, then the particle moving with uniform velocity will show a graph of this sort, which is making an angle of theta with the horizontal. So, the slope of this particular graph, now slope of a straight line, you must have got this. So, slope of a straight line is given by tan of the angle. So, slope of this particular line is tan theta, which will give you the measure of the uniform velocity. of the particle. Now let us try and understand this with few illustrations. Now we shall begin with uniform velocity. Suppose we have here the displacement and this is the time. Suppose the time is 0 second and the particle is not showing any change in position, that's also 0, and time changes by 1 second, say. This is in second and this is in meter. So time changes by 1 second, displacement is changing by say 50, 2 seconds, 100, 3 seconds, 150 and so on. Now if we try to plot this, displacement versus time. This is displacement versus the time. So if you plot this, 0, 1, 2, 3. In second, this is in meters. Here we have say 50, 100, 150, 200. So if we plot these points, we get a graph of this sort. This is the first point, this is the second point, third point, the fourth point. You can just draw the lines and get the graph. So we see that the displacement time graph of a particle moving with uniform velocity is a straight line passing through the origin. This passes through the origin, which indicates that the particle was initially at rest at 0 time. Now if the particle would have had some position, then the graph wouldn't have started from origin. So this is how a particle behaves when it is moving with uniform velocity. Now next we come to variable velocity. A particle is said to have variable velocity if its speed or direction or both changes with time. So if the speed of two particles remain the same, say, but they are moving in different directions, then also we say that the particle is moving with variable velocity. But if we see that the speed changes but the particle is moving in the same direction, then also we will be saying that the particle is moving with variable velocity. So try to get a hold of the different cases that may arise in numericals. So suppose a particle is moving in this particular direction, say with a speed of 2 meters per second. We give the points as A and B, and then it continues moving in the same direction, but now with a different speed, say 3 meters per second. In this case the direction is same, but the speeds are different. Then we will be saying that the particle is moving with variable velocity. And if this is the case, particle is moving with 2 meters per second in the west direction and then it moves due north with the same speed. In this case also we will be saying that the particle is moving with variable speed. And if such a case arises in which the particle's speed as well as direction are changing, then also we can say that the particle is moving with variable velocity. So suppose due west the particle is moving with a speed of 2 meters per second and due north the particle is moving with a speed of say 3 meters per second. Under these circumstances also we will be saying that the particle is moving with variable speed. Now instantaneous velocity, this is very similar to that of instantaneous speed. That is, if a particle is moving with variable velocity, then the velocity of the particle at any particular instant of time is the instantaneous velocity. Now average velocity. Average velocity is defined as the ratio of the total displacement to the total time taken. So we can write a formula for average velocity here. Average velocity equals total displacement over the total time. Now if the displacement is 0, then what will be the average velocity? That also will come up to 0. Now I call them helpers. Let's have a look at this. So these are my favorite. Okay, so we have the position time graph of a particle. This was just the case I was talking a bit before. If you can see that the position time graph of the particular particle is not starting from 0, which means that it has some initial position at time t equals 0. So we have the position time graph of a particle, say in a numerical problem, and you are asked how do we find out the velocity of the particle. So you have to understand that the slope of this straight line will give you a measure of the velocity. Now another important bullet point which you have to remember, greater the slope of the position time graph, greater will be the velocity of the body. Now here we have taken the case of two bodies A and B. A makes an angle of 30 degree with the time axis, while B is making an angle of 60 degree with the time axis. So let us find out the slope in either cases. Slope of A. It's given by tan of the angle, that is tan 30. Now tan 30 is root 3. So we have, let me make a change to this, tan 30 is 1 by root 3. Sorry for this. Now similarly we find out the slope of B, which is tan of 60 degree, which is root 3. Now you can see from here the slope of B is greater than the slope of A, which means that the greater the slope, greater will be the velocity. So this tells us that the body B has a greater velocity than body A. So we can write here, slope of B is greater than slope of A, or we can write that velocity of the body B is greater than velocity of body A. Now the displacement of a particle is equal to the area under the velocity time graph. You can see the velocity time graph of a particle which is moving with uniform velocity. How do I say this is uniform velocity? You can see that with change in time the velocity doesn't show a change, which means that the particle is moving with uniform velocity. Now if we take any 2 points on this graph, say this is point A and this is point B. Now if you are asked to find out the displacement or the change in position of the particle in going from A to B, how will you do that? So that is simply the area under the displacement term graph. So this particular shaded region, you can see the area of this particular rectangle. If you are finding out, then you get the displacement of the body in moving from position A to the position B. So we come to non-uniform motion. We are over with uniform motion and now we shall be discussing non-uniform motion. Now what is non-uniform motion, or what is the concept of acceleration? Now a particle is said to be in non-uniform motion if it covers unequal displacements in equal intervals of time, however small these intervals might be. So time is changing uniformly, but if the position of the particle is not changing by equal amounts, then that will be a case of non-uniform motion. Now to be remembered here, in case of non-uniform motion, the velocity does not remain constant. These small points you have to remember so that you can apply these concepts to numerical problems. Now let us look at what is acceleration. Now acceleration is basically the rate of change of increase in velocity with time. You can see the velocity time graph of a particle. Now when it is a case of acceleration or positive acceleration, the graph is somewhat like this. Now deceleration or retardation is defined as the rate of decrease in velocity with time. Suppose time increases but the velocity of the particle is decreasing and the particle is trying to come to rest. So that is a case when we say that the particle is getting retarded. So this is negative acceleration or retardation. Now if we want to represent both the scenarios under one picture, then this will help us. Now you can see the region AB signifies acceleration, the region BC indicates uniform velocity because the velocity is not changing for this region with increase in time, and then for the region C and D you can see that as the particle goes from C to D, time increases but the velocity of the particle shows a decrease. So this is a case of retardation. Now talking about the equations of motion for a uniformly accelerated body. So these are very important equations and we shall be using them thousands of times in our career. Now let us have a look at the basic equations. We have one equation that I will be writing initially. Distance is equal to speed into time. This is one of the equations. And then we come to the equations of motion for a uniformly accelerated body, which is V equal U plus AT. Then we have S equal UT plus half of AT square. And finally, V square equal U square plus 2AS. Now, what is U, what is V, what is S? Let me clear this out with a diagram. Suppose we have a particle here at position A. The velocity of the particle is given by U. This is the initial velocity. The particle is moving and it is covering a distance S in a time t and it reaches the position B. And when it reaches B, it has got a velocity V, which is its final velocity. Now, it is obvious that the velocity has been increasing, otherwise how will the particle be moving from A to B? So the acceleration involved is given by E. Now, you can see this equation, this is nothing but the definition of acceleration. We know acceleration is nothing but the rate of change in velocity over this is time. Okay, so this acceleration is nothing but the change in velocity V minus U over time. From this definition we can get this formula. If we transpose this, we get AT and then V will be equal to U plus AT. Similarly, we can get these equations applying simple laws of geometry. So these are the equations of motion for a uniformly accelerated body. What if a body is falling freely under the action of gravity? These equations will remain the same. The only difference to it will be that in place of acceleration, we will write g, little g. Little g is the acceleration due to gravity. It varies from equator to the poles, but for simplicity, we will assume its value as 9.81 meter per second square. So let me write those equations for a freely falling body. So we have for a freely falling body, you can say this here, for a freely falling body, the equations change in this manner. This is V equal U plus GT, H equal UT plus half GT square and V square equal U square plus 2GH. Here S is substituted by H, which represents the height attained by the particle. Now this particular formula is to be noted. This is an important formula. This is the distance covered by a body in the nth second. Now let me explain this with a diagram. Suppose the particle was initially at A. It comes to the point B. Now, the total distance covered is s. This particular time is the nth second and this is the previous time, that is the n minus 1th second. So, the distance travelled in total n seconds is given by Sn, and the distance travelled in n minus 1 seconds will be given by Sn minus 1. So, the distance covered in this nth second is given by Snth, which is nothing but, we can write this as equal to Sn, that is the distance travelled in n seconds, this is Sn, minus the distance travelled in n minus 1 seconds, that is this much distance. This is Sn minus 1. So, how much distance it is covering in the nth second? It will be simply a difference between these two terms. Now, time for helpers again. You can see, if velocity and acceleration are pointed in the same direction, the object speeds up. How do we understand this? You take a ball, throw it up. What will happen? You will see that it will go up till a certain height and then come back, isn't it? So, what is happening actually? We know that whenever any body is trying to move against the pull of the earth, it is trying to move against gravity, and then it is being retarded by gravity. That is why they are saying that whenever the velocity of a body is opposite in direction to the direction of gravity's pull, then the body will get retarded, or the vice versa. We can think of that. That is, if velocity and acceleration, they are pointing in the same direction, then the object will speed up. Now, gravity always provides a constant downward acceleration. If acceleration is at right angles to velocity, the object changes direction. So, let us try to understand this case. It is the case of circular motion. You must have seen an object moving in a circular path. Now, at every point of motion, its direction goes on changing. And what is the direction of the acceleration at any point? The acceleration is always directed towards the center of the circle along the radius. So, this is the case of uniform circular motion. Now, let us discuss some conceptual problems on these topics. Is the following graph possible for a particle travelling along a straight line path? You can see this is the speed time graph of a particle. With increase in time, speed increases then decreases. But wait, just have a look at this portion. In this particular region, the time is increasing but the speed is becoming negative. Can speed become negative? No. Why? Because speed is a scalar quantity. So, it can only be positive. It can never be negative or zero. So, this sort of a graph is not possible for a particle. Interpret the physical meaning of the following graph. So, this is very easy and quite clear if you have understood the concepts properly. Just have a look at this. When the particle is moving from A to B, it is the velocity time graph. So, when the particle is moving from A to B, its velocity increases. So, this is a clear case of uniform acceleration. When the particle is moving from B to C, it is getting retarded. When the particle moves from C to D, the velocity is constant. So, this is the case of uniform velocity. And when the particle follows this path, D, E, F. Can you say what is this? Yes, the particle is moving with a variable velocity for this particular region. Now, is the following graph possible for a particle? Let's have a look at this graph. We can see it is the position time graph of a particle. Now, choose any time on this graph. Suppose we are choosing this particular time. You can see that for a particular time, we can have two possible positions of the particle. Is this possible? Can a particle be at two different positions at a particular time? No. So, this sort of a graph is not possible for a particle. Can the velocity of a particle vary if its speed is constant? Just now we talked about it. Circular motion. Whenever a body is following a circular path, it is possible that its speed remains the same, but at every point of motion, the direction will vary, which will cause the velocity to vary. So just have a look at this. At any point of motion, velocity is along the tangent. So you see that any point of motion, the velocity changes, the particle will change its direction. So change in direction means that velocity is also changing. Now we have the acceleration time graph of a body. What will be the total change in velocity? Now you can see the acceleration time graph of a particle. What will be the change in velocity? Now recall the definition of acceleration. Acceleration is the change in velocity with time. So we have this graph, and the area under this graph will give us the acceleration of the particle, and also the total change in velocity can be calculated from the area. So the shaded portion, this is nothing but a triangle, and we know the area of a triangle is half times the base times height. So we will find out the change in velocity from that. Change in velocity equals area under the graph. So this is half times the base times height. So put the values, we get it as half times the base is 5 seconds and the height is 4. So this is 10, and it is the change in velocity. So unit of velocity, 10 meter per second. Now can a body have zero velocity and finite acceleration? Just now I was talking of such an example. You take a ball, throw it upwards. It is being continuously pulled by gravity. So its motion is getting retarded. As a result, when this body reaches the highest point, at that point its velocity is zero, but it still has some finite acceleration due to gravity. Now we come to numerical problems. There is a hyperlink to the formula sheet. You can refer to that whenever you feel like while solving the numericals. Now this is the first numerical that I have in store for you. The displacement x of a particle moving in one dimension under the action of a constant force is related to the time t by the equation t equal root over x plus 3, where x is in meters and t in seconds. Find the displacement of the particle when its velocity is 0. So we are to find out the displacement of the particle. So let us rearrange this equation so that we get an equation in x. We have t equals root x plus 3. We'll just rearrange this. Root x equals t minus 3, or squaring both sides, we can see that x is equal to t squared minus 6t plus 9. Now take a look at the question. They are asking us to find out the displacement of the particle provided the velocity of the particle is 0. Now try to recall the definition of velocity. Velocity is the change in displacement with time. So we can write velocity v equals dx dt. So we will differentiate the above equation and we get it as 2t minus 6. Hopefully you know the basic formulas for differentiation. I will write this down. ddx of x to the power n is equals n x to the power n minus 1. So this particular formula has been used here in solving this problem. So we have velocity which is equal to 2t minus 6. Now by question we have velocity is equal to 0. Therefore we can write the right hand side as 0, that is 2t minus 6 equals 0, which will give us t equal 3 seconds. Now we have found out the time, we need to put it in this equation for x to get the value of the displacement. So we can write displacement x equals t square, which is 3 square minus 6 times 3 plus 9, which will give us a displacement of 0. So this is the solved one. You can refer to this anytime. Now we come to the second question. So we have a train which is travelling from one station to another at a speed of 40 km per hour and returns to the first station at the speed of 60 km per hour. Calculate the average speed and average velocity of the train. Now let us try to solve this problem on our own. We have, so you must be remembering the helpers that we came across, the average speed, the formula when a particle covers the same distance but with different speeds. Yes, we shall be using that formula. We have a train that is moving from one station to another. This is say station A, this is say station B. It is covering the same distance and with different speeds. For the first case, the speed is say 40 km per hour, and when it returns back, the speed is 60 km per hour. Now, it's very easy to find out the average velocity. Average velocity is the total displacement over the total time. So we can see that the particle is going from A to B and coming back to A, which makes its displacement as equal to 0. So we can directly write here, we will write the formula for average velocity and directly put the answer. So average velocity equals total displacement over the total time. So the displacement is 0, which gives us the average velocity as 0. Now for average speed, we shall be using the formula S1 S2 over S1 plus S2. So here S1 is 40, S2 is 60, and in the denominator we have 40 plus 60, which is 100. So we get it as 48 km per hour. So hasn't the helper helped us really? Now another beautiful example for you. A body travels 200 cm in the first 2 seconds and 220 cm in the next 4 seconds. What will be the velocity at the end of the 7th second from the start? So let us try to solve this. In the first 2 seconds, the body covers a distance of 200 cm. This is in a time of 2 seconds. And in the next 4 seconds, it is covering a distance of 220 centimeter. Now you are asked to find out the velocity at the end of the 7th second. So from start, this much time is 7 seconds, and you are asked to find out the velocity of the body here. Okay. Now we shall try to write equations for this. Now have a look at this, the trick in this question. For the first 2 seconds, it is covering a distance of 200 centimeter. So we shall be using one of the equations of motion, S equal ut plus half at square. So this S is 200, initial velocity is 0. So this first term disappears. Oh sorry, this t is 2 seconds. This initial time is 2 seconds. So we have u times 2 plus half a, the acceleration, it's not given. This is again 2 square. So we have an equation 200 equals 2u plus 2a, or we can write u plus a equals 100. So this is one equation that we have in hand. Now for the second case, take a note at the diagram. In 4 seconds it is covering a distance of 220 meter. But if you consider the position right from the beginning, it has covered a total distance of 200 plus 220, that is 420 centimeters in a total time of 6 seconds. So this is the trick in the question. If you do this part wrongly, then you will get the whole sum wrong. So take a note at this. So this is the total distance will be 220 plus 200. So this is say S2 in 2 seconds, and now we will write this as S6, which is 200 plus 220. 420 centimeters, and the time will be 6 seconds. U times 6 plus half of a to 6 square. So we will solve this. We get it as 70 equals u plus 70 equals u plus 6a. So this is the other equation that we get. Now we will solve these two equations and we can get the value of a and u from this. Now we can see, if we try to solve these two equations, we will get 5a equal 30, or we can write a equals 15 centimeter per second square. This is minus 30, because you can see it is 6a minus a, 5a, and then 70 minus 100, which is minus 30. So we have a negative acceleration of 15 centimeter per second square. Now we can put this value of a in any of the equations and get the value of the initial velocity, which comes out to be 115 centimeter per second square. You have to do a bit of calculation. Now we are asked to find out in the question the velocity at the end of the 7 seconds from the start. So we have these things in hand, the initial velocity and the acceleration, and we are asked to find out the velocity at the end of the 7th second. So we can use the equation of motion v equal u plus a t. We are asked to find out v, u, we have just now got the result 115, a is negative 15 and time is 7. So ultimately this comes out to be 10, comes out to be 10 centimeter per second. Now the next problem, it's an alpha particle. Okay, we shall try to solve this on our own. Now we have an alpha particle which is travelling along the inside of straight hollow tube, 2 meter long, of a particle accelerator. Under uniform acceleration, how long is the particle in the tube if it enters at a speed of 1000 meter per second and leaves at 9000 meter per second. What is its acceleration during this time? So we have two things which we have to find out in this question. One is the time and the second is the acceleration. Now whatever is given, we'll write down from the question. The length of the tube, that is the total distance which the alpha particle covers. So that is S. Distance covered is 2 meters. We have the initial velocity, which is 1000 meter per second, and we have the final velocity, which is 9000 meter per second. So the first thing that we do is we find out the acceleration of the particle. We use the formula v square equal u square plus 2as. From this formula, if we try to find out a, it is equal to v square minus u square over 2s. We put the values. This is 9000 whole square minus 1000 square over 2 times 2 meters. So we will solve this and we get the result as 2 into 10 to the power 7 meter per second square. So this comes out to be 2 into 10 to the power 7 meter per second square. So it's not that hard to be done. 9000 can be written as 9 into 10 cube whole square. So this gives us 81 into 10 to the power 6 minus this is 1000, that is 10 cube whole square, so 10 to the power 6, and you can take 10 to the power 6 common. So we are left with 81 minus 1, that is 80, and the denominators are there which will cancel out 8, and then we are left with the final answer. So this is the acceleration. Now to find out the time, we will use the definition of acceleration, a equal v minus u over t, or we can write t as equal to v minus u over a. So v is 9000 minus u is 1000 over a, we got it just now, 2 into 10 to the power 7. So this gives us a time of 4 into 10 to the power minus 4 seconds. Now another sum of the same kind. A particle, this is one of my favorite sums. You will very soon understand why. A particle starts with an initial velocity of 10 meter per second and moves along a straight line with a constant acceleration. When the velocity of the particle is 50 meter per second, the acceleration gets reversed in direction. Find the velocity of the particle when it reaches the starting point. So the particle has started from a point with some velocity, it reaches a point, by the time its velocity has already changed, and then it comes back to the same point, but while it is doing so, its acceleration gets reversed, and we are to find out the velocity of the particle when it reaches the initial point. Now let's have a look at how to do this. So this was our sum. Initial velocity. This was the point, the body moved say from A to B. The initial velocity is say u, and it is given as 10 meter per second. It reaches this particular point with a velocity of 50 meter per second, and then it comes back. Now during the start journey, suppose the acceleration was a, and during the return journey the acceleration is reversed, that is it will be minus a. Now we shall be using this particular formula, v square equal u square plus 2as. We have v for the start journey, this is for the start journey. V square is 50 square minus this is 10 square plus 2as. We have this as 2500 equal 100 plus 2as. So we are left with as equal 1200. Okay, let us mark this equation as 1. Now for the second part, find the velocity when it reaches the starting point. Now for the second part, we have to be careful with the signs. Let us use the same equation. Now this is for the return journey. Now v square, we do not know that. We are asked to find that out. Keep this as it is. U square. U is now 50 because the particle started from here and it ended up here. So U is now 50 plus twice of A. A is negative here because the acceleration got reversed, and displacement will take this as minus s. Why? Because the direction is opposite. This is just to indicate the direction, nothing else. So we have v square, which is equal to 2500 plus 2as. We'll put the value of as from equation 1 and we get v as equal to 70 meter per second. So here comes the trick of this particular sum, which makes this one of my favorites. Look at this. The particle had a velocity of 50 and then it finally ended up with a velocity of 70. Okay? But this is a case of deceleration. You have to remember that, which means that the velocity, by the time it has reached the point A, the velocity is in the opposite direction. So we'll write v as equal to minus 70 meter per second. So the velocity of the particle when it reaches the starting point is minus 70 meter per second, where the negative sign simply indicates the direction of motion. Now look at this problem. A balloon is ascending at the rate of 12 meter per second. When it is at a height of 65 meter from the ground, a packet is dropped from it. After how much time and with what velocity does the packet reach the ground? Now this is another beautiful formula and we shall try and solve this now. So the balloon was ascending. Its velocity, we can write it as u, which is equal to 12 meter per second. This is the velocity of the balloon. Now we are not concerned with what the balloon is doing because the problem is mainly based on the packet which is dropped from the balloon. So just think of this as a picture. The balloon was ascending with a particular velocity, but then at this particular height, which is 65 meter, the packet is dropped. Okay. So the initial velocity of the packet will be the same as that of the balloon. But mind it, the packet is falling downwards, but the balloon was ascending upwards, which gives us a hint that we have to use or we have to write the velocity of the packet as negative of that of the initial velocity of the balloon. So the velocity of the packet, better spoken, it is the initial velocity, okay? Initial velocity of the packet. It is u equal minus 12 meter per second. So hope you understand where from this minus sign comes. Now we are asked to find out the time taken by the packet to reach the ground and the velocity when the packet reaches the ground. So two parameters are to be found out here. Now let us first find out the second parameter, that is the velocity. We shall use the formula v square equal u square plus 2as. Now what is v? V is the final velocity which we are asked to find out. What is u? This is minus 12 whole square plus 2. This is downward motion, and we know gravity always acts in the downward direction. So this is, it is actually 9.8, but they have asked us to take the value as 10, so we will take that, and S is 65. So we get this as 144 plus 300. So this is 1444. V square is that. So V will be equal to 38 meter per second. You can find out the square root of 1444 and we get this result. So this is V, and now it's very easy to find out time. Time we will find out directly from the formula for acceleration, that is T is equal to V minus U upon A. So we have V as 38 minus U as minus 12 upon A, which is 10. So we get this as 5 seconds. So the time taken by the packet to reach the ground with a velocity of 38 meter per second is 5 seconds. So this brings us an end to uniform and non-uniform motion. We have covered almost all the topics, we have provided real life examples of it, and we have also discussed some very important numerical problems. Next, we shall be talking about projectiles and their motion. Thank you.